ready to show you some exciting new features that our product and development teams are currently building into Sigrid. And these new features will support an enterprise architect or solution architect in common use cases and modernization scenarios. So to go over these features and introduce them to you today, I'd like to talk about a common modernization scenario that we see at our customers. And that is that there are too many different front-end technologies leading to different UIs. There can be all kinds of reasons why that is. Sometimes it's because an acquisition where a team just inherited different technology stacks. It could also be that there's no common architecture vision and everybody in the past could just pick and choose whatever they wanted. The impact of this, however, is that users are confronted with different UIs, which can lead to confusion or buttons being replaced or repositioned all the time. In any case, today we will show you how you can use Sigrid to, for instance, create an impact analysis on if you want to replace a certain component or multiple components. What are the options that you have? Vijay will go over that. Then I will get into basically a completely new tool that we're building. We call it a scenario builder, and that supports an enterprise architect to create a plan around this modernization. And then Shima will close and she will talk about the actual execution of such a project and how you can make sure that you keep it within your non-functionals. So without further ado, Vijay, you're up.
Thanks, Jasper. Now let's take a look at our Sigrid platform, specifically the architecture module, to see how a solutions architect would go about doing an impact analysis of our system. So to provide you with some context, what you're seeing on your screen here, on the left-hand side, those hexagonals are the 6 quality characteristics of a systems architecture. And on the right-hand side are things that you can measure within the code base. And on the top bar, what we can do within Sigrid is that also compare this system with other systems that we've analyzed and provided with a rating. And so what we're seeing here is that our system is of average architecture quality based on compared to the benchmark. But there are a couple of areas where it's rating below market average. That's around knowledge and evolution. So let's take a look to see how we can evolve our system, specifically the front-end components, for a better user experience. So for that, I'll go to our Explore Architecture tab. And here, what we're seeing here is that each of these boxes are a top-level component, and the lines across these boxes are the relationship between them. So if I hover over the user icon, I see that the system has 2 front-end components here called UI Viewer and UI Portal. So now I'd like to see, as a solutions architect, how easy it would be to refactor these components. And for that, one of the first things I would be looking at is the dependencies or the isolation of these components so I can make changes to them. So for that, I'll go to our Component Coupling tab, and so what I'm seeing here is that our UI viewer is actually quite highly coupled with other components within the system at the top layer. Let me take a deeper look at it. Oh, wow. Now it looks like a bit of a mess. So we could see that not only is the top level coupled with the rest of the system, but also the modules or the subcomponents within the UI viewer also has dependencies across the system, which actually leads me to believe that there might be some business logic lying within the front-end layer, which is an architectural anti-pattern. And this does not look like it would be easy to refactor this front-end layer without impacting the rest of the system. So let's look at the Component Cohesion tab. And here, yes, so we do see that typically what we'd want to see is that the modules or subcomponents within a top-level layer component follow a single responsibility principle. That means that the things that they have or designed or requirements that they're implementing are specific to that layer or that business requirement. But given the dependency within the sub-modules here and across the other components within the system, it makes me believe that there would be a lot of business logic within the front-end layer, which is another anti-pattern. So, and of course, in a real-world system, we'd be looking at a lot deeper and talking to the development teams to validate our findings. But just for the sake of this demo, I think I can form a conclusion that doing a refactoring of the front-end layers would be too costly because of the high coupling and the lack of cohesion within the front-end layer. So what I would recommend is doing a rebuild of the system in the form of consolidating the front ends and, of course, pulling out any common UI artifacts into libraries that could be reused in the future, and also make sure that the business logic is extracted from the front-end layer during the rebuild process, and they're built into their own services that can be reused for the future. So another area I'd like to focus on is the knowledge distribution. This is also scored poorly within our benchmark average, and let's see what we can find here. So with knowledge distribution, what we do is we take the git commit history or version history, and we aggregate the data to see how evenly distributed knowledge is across development teams. And here, what we're seeing here is that the blue line shows that it looks like there's less than 2 or 3 people that are actually working on the system, and the yellow line is what the theoretical recommendation would be. So what I would recommend here, or what I would conclude here, is that it looks like there's knowledge monopolies or the team is highly understaffed. So this causes the risk for this is that by causing knowledge monopolies, you're creating single points of failure, and it becomes very difficult to scale and evolve the system as well, architecturally. So let's go back to our summary. So now, of course, as I mentioned earlier, in a real world scenario, we would be diving a lot deeper into each of these architectural characteristics, working with the development teams to validate them and coming to conclusions. But just for the sake of this demo, I hope it was a good view of how our solutions architect can go about doing this and providing recommendations to the enterprise architect. Back to you, Jasper.
Thanks, Vidya. So now we get into a new page that we're currently building. It's called Modernization Scenarios. There's quite some information and a lot to unpack here, so let me just walk you through what we see on the screen. So in this table, we see a full list of all the systems that make up the portfolio that is under the responsibility of the enterprise architect. We can toggle open this system, and then we see the components that make up that system. There's some information here to provide context. On the one hand, we see business context, where we can look at the criticality and the life cycle of a system, and we see also technical context, essentially showing us how large the system is in person years, what the maintainability score is, and how the architecture scores. Now we get into the exciting new stuff: scenario input and scenario outcome. And to explain these, I'd like to go into that system that Vidya just did an analysis on. So let me scroll down here, and there it is, Artemis. So you can see in the decision that when we toggle open this drop-down menu, there's a whole range of different modernization scenarios we can pick from. And what Sigrid does very well is it uses the maintainability and architecture scores, and it also uses our benchmark to essentially provide us with an effort estimation and a period in when this project is done. So in this case, Vidya chose that for Artemis, we actually want to rebuild this. So when I click on that, what you can see is that the total effort is being computed. So it's roughly 30 person years. And with the current team commit, this will take around 5 years. So when we load this up into our planner, we can see this here visually. But we also know that there's actually more people working on this particular project. So this estimation comes from our architecture quality module. But in this case, we know that we want to commit more people to it. So let's imagine that there's actually 20 people working on this, and that our commit is half of the team. So this could be two Scrum teams, maybe we commit even more, like 12 FTE. And you can see that that reduces the period in which this modernization scenario is being executed. Now let's load up a few more systems. So just to show that you don't necessarily have to select a modernization decision on the system, you can also do this per component. So when we toggle open Bitcoin here and scroll down, then we see, for instance, the wallet. The wallet is relatively small, so we don't expect a huge impact, but we know that we need to, for instance, replace this. Again, Sigrid comes up with an effort estimation. We can load that up into our scenario. So let's scroll down even further and we get into the somewhat smaller systems. So let's go for instance, Electron here. We're going to refactor that one, so load it up. This takes a little bit too long, so let's imagine that our commit is going to be a little bit higher. Let's load up Django 2. Re-architect that. Our commit is going to be higher too. So yeah, well, let's imagine that all of these 4 systems, those were the systems that had front-end technologies. So you can see a total effort that we expect that this project will take, 35.5 person years. But after its completion, we assume, of course, that the quality will increase of the components or systems that we selected, and that will reduce a total maintenance effort. So this is information that an enterprise architect can use to have a conversation with other stakeholders, for instance, management teams who need to commit the time and the effort that we need to invest to complete this modernization. The conclusion could be that it needs to be faster. Well, we know what we need to do when that's the case, then we need to commit more FTE. So this is where we are today. Very interested to hear feedback, of course, on this page. We think we're onto something, but let's now go into a very practical way to help teams understand what non-functional requirements are and how they can work together to make sure that we develop according to those guidelines. So for that, Shima will now take over. Shima, you're up.
Thank you, Jasper. So that's right. The enterprise architect and the team have decided, as a result of the modernization, that they would like to make some updates to a system or 2 systems or 3 systems. And I would like to show you how you can do that. When you want to make updates, you would like to have some sort of executable objectives to know, okay, if I'm making progress or how are we progressing and when should we decide to readjust or where to go from now. So with Sigrid, I would like to show you how you can do that. And right now where we are is the portfolio dashboard. Here you have a view of your overall health of the systems in your portfolio. And on the top, you see all the cards that are related to the non-functional qualities. For example, the first one is the maintainability at 2 stars, that's benchmarked against the market. And you have the security, which is based on the maximum critical findings. At the moment, you see a very deep red, and that is an indication that you might need to make some fixes here. With open source health, you can see that you have 37 systems with high risk findings, and that's what the color indications here mean. At the bottom, you have the tree map where you can see the systems, and on the side, you can see the total number of systems and the build volume. So going back to the scenario that Jasper was presenting, we would like to take a look at the system and maybe talk about some objectives that the architect and the development team have set. So filtering to have a better view of my systems based on the architect team, and now I can see these 2 systems. And I would like to select Hadoop. I can select it from the tree map, or I can go to the system and in the table and search for it. So now I'm migrating to the systems dashboard. And here what I will get is everything about the system against these non-functional parameters. Right now I can see that maintainability is 2.6 stars, critical finding, 90 critical findings, hundreds of findings with high risk for the open source health, so on and so forth. There are also additional details that you can find about the system, as well as the metadata, for example, the team, the division, so on and so forth. Currently, no objectives are set, and let's do that together. Imagine that the enterprise architect and the team have sat down and decided that the systems should have a maintainability that is at least 4. And let's say that for the next sprint, they would like to bring, to get rid of all the high risk and bring it down to just medium risk. And then maybe they can sit down again and then make adjustments on the next sprint. So I will go to the edit and open the maintainability. Here I have the system objectives. We decided that we would like to have a maintainability of 4 and an open source health risk of medium only. So now I saved it. Let's take a pause and also imagine that some period of time has passed on and the development team have been making updates and coming here to check their progress in the meantime as well. And it's time to have some sort of planning or discussion again about the progress of the system or where we are. So I'm going back to the overview, and what I see is that the maintainability score we decided to be 4 stars, and it is still 2.6, and the medium risk for open source health, and I can see that, hey, we still have high risk findings. So at this stage, it's a good time to also talk to the team and decide, hey, was this executable objectives? Was this actionable? Or why were we not able to reach these goals? So during this time, you can readjust or re-strategize. You can come back and do this on a regular basis and make this a part of your process and make quality a part of your workflows.
Sigrid supports architects and stimulates collaboration between teams, from developers to C-level. Get practical examples on how to agree on shared goals with teams. Convey the return on investment for architecture modernization, and track architecture changes with Sigrid.